It's a question 62 from the yellow book. It's relatively simple, but still it just actually involves every part of my discussion of my slide about the matrix type linear maps. So here we go. We have to recover a map between these two vector spaces as the vector spaces of polynomials of degree 2 or less. We have to recover this map under the assumption that this G map is basically the A, B, C map from my previous slide. So it's a matrix type linear map with respect to the matrix A, basis B and basis C, B basis in the domain, and C basis in the codomain. So the B basis is the basis consisting of these three polynomials, E0, E1, E2. C basis is the basis consisting of the same three polynomials, E0, E1, E2. E0 is the constant 1 polynomial, E1 is the x polynomial, E2 is the x square polynomial. And the A matrix from the question is this matrix, 1, 2, negative 1, negative 1, 1, 0, 3, 4, 1. That's a 3 times 3 matrix with real numbers. Here's the setting. So we have to recover the map G, which is the matrix type linear map of type 2 from my previous slide, depending on these three input components, A, B, C, and the components right in front of you. The question is not really it's not really a difficult question. You just have to, it just checks whether you really understood what is the matrix type map of the type 2 from my slide before. There are a few other questions of the same nature. I encourage you to do that questions on your own. So here we go. I take a polynomial, because I take a polynomial from here of degree 2 or less. Every such polynomial admits a representation of this type, A0 plus A1x plus A2x squared. Now I'm going to frame this polynomial in the context of the basis, B, in my domain. That's how I'm going to do that. P, you see I'm dropping the x presence from my notations because now I operate on polynomials as vectors. So it's the entities with no any values or functions. So P is a linear combination of my basis like this. A0 times E0 polynomial, A1 times x, which is E1 polynomial, and A2 times x squared, which is E2 polynomial. This is a linear combination of basis vectors with the coefficients A0, A1, A2, which means that the coordinates of my P with respect to the basis B is A0, A1, A2. You can equally say, using my new notation, that the same thing is the same triple of numbers is effectively the I sub B of P. That will be another way to say it. That's another good way to say it, actually. So it's the first stage of my map. Remember, my map consists of 3 stages. That's the first stage. Now, second stage is here. Now x not supposed to be here, and here is supposed to be B, actually. That's my second stage. That's the actual matrix map. When I multiply my triple by the given matrix, here's the multiplication. Here's my matrix, 1, 2, negative 1, negative 1, 1, 0, 3, 4, 1, and here's my triple, A0, A1, A2. We all know how to multiply matrices. Here's the result of the multiplication. First, it will be the matrix of size 3 rows, 1 column. So I dot product the first row here with the column here. It will be A0, take a 2A1s, plus 2A1s, take a 2. Now the second dot product is the second row and the column here. It's negative A0 plus A1, and the last dot product is the last row and again the only column in the second factor, which is 3A0, 4A1 and 1A2. That's the second stage of my type 2 matrix type linear map. And that is the coordinates of my result with respect to the C basis. Here it is. Now the result itself, G of P, will be the elements of my C basis combined with this coefficient. Here's the combination. First coefficient, A0 plus 2A1 take A2 times the first element of the basis, E0. Second coefficient, negative A0 plus A1 times the second element of the basis, E1. And the last coefficient, triple A0 plus 4A1 plus A2 times the last element of my basis. If you now replace back what the basis was in terms of the x variable, the resulting polynomial, and now you see my x is back into the picture. And if you combine, if you recombine the things a little bit, that will be the A0 times this polynomial, because it is A0 times 1, negative E1, that's why negative x, and plus E2, sorry, plus 3 E2, so it's a 3x squared. That's the coefficient next to A0. Coefficient next to A1 will be double 2 plus x. Actually, I missed that coefficient. Let's see that there's a typo here. And that's the coefficient next to A2. Is that right? Negative 1 and plus x squared. So there's one typo in my presentation here. Supposed to be plus 4x squared. And that's a linear map in the question TQ60. In the question 62, fully recovered.